number 3 on the board. Continuing our functions in real life. A user is charged 250 pesos monthly for a particular mobile plan, which includes 200 free text messages. Messages in excess of 200 are charged 1 peso each. Represent the monthly cost for the text messaging using the function T of M, where M is the number of messages sent in a month. So again, let us identify your independent variable and your dependent variable as well as your constant. So your independent variable or your domain or input on our problem is the number of messages denoted by M, and our output or the dependent variable is the total cost. So the total cost each month, okay, or the monthly cost of the mobile plan, denoted by, as specified on our problem, we will denote it by T. Okay, and our constant is 250 pesos. Okay, then the resulting function is T of M. Okay, and number 3 example is a piecewise function. And by definition, your piecewise functions are functions that requires more than one formula in order to obtain the given or unknown output. Okay, so I will write your piecewise function here, denoted by P of M. Okay guys, so a piecewise function is identified with this symbol, the open brace. Okay, so a piecewise function is a function that requires more than one formula. It has more than one domain or condition for us to obtain the given or unknown output. So let's try to understand it more using this example. So T of M, or M function of T, is equal to, okay, so we have 250 if, so 250 is your monthly charge or payment. If you are using a mobile plan, you will pay 250 pesos monthly when you are using 200 free text messages. Okay, so we will put the domain in here or the condition. You will pay 250 pesos if you are using free text messages from 0 to 200. Okay, and M is on the middle. Now we will write the symbol. So your boundary is 200, and that will be equal 200. Okay, equal 200 and less. Okay, so we can read this notation as m is greater than 0 but less than or equal to 200. Just look at the symbol. So if we have three variables or quantity, we will read this notation from the middle. So we have m is greater than 0 but less than or equal to 200, or we can read it this way: m is less than or equal to 200 but greater than 0. Just look at the point and the opening. So the opening will, this one, the opening will denote the greater than notation, and this point denotes less than, just like this one. If we will read from m to the right, m pointed, so we can read it as m is less than. Okay, but if we will read it to the right or to the left, I mean, we can see this opening, so we can say that m is greater than 0. If we will read from 0 to m, we can say that 0 is less than m because it is pointed. Okay, so for those who are confused with the symbol of greater than and less than, so just look at this one. So equal symbol is denoted by a parallel lines. So the distance here and here are equal. So this denotes that this value is equal to this value. Okay? So we can say that 2 is equal to 2 because this one, the distance of parallel lines are equal. Okay? So parallel lines denotes equal symbol. If these two lines uh, on the left is pointed and opens on the right, we can say that the quantity on the right is greater than the quantity on the left. Okay? If the symbol opens to the left and points to the right, we can say that the quantity on the right is less than the quantity on the left. So just mind the opening and where it points. Okay? So that you will not be confused. Okay, so again, let's go back to our domain or condition for your piecewise function. So m is greater than 0 but less than or equal to 200. If we try to present it using a line graph, we can say that this is from 0 to 200. Okay, so if we will use this 200 text messages, we will pay 250. Let's say you used 100 text messages, so you will still pay 250. If you used 150 messages, you will still pay 250. So from 0, or I mean greater than 0 to 200, you will pay 250. Okay? So if you didn't use any text messages, you will still pay 250 pesos. Okay? Now let's proceed to the other domain or condition or formula. What if you use more than 200? So 200 is our boundary. So this is 0 and this is more than 200. Okay? So in this range of values, you are paying 200 pesos. What if you use more than 200? So you will pay 250 plus the excess of 200. And each excess is charged by 1 peso. So we will put a quantity of excess. So we have M minus 200 if M is greater than 200. So example guys, so this is the boundary 200. What if you use 201 text messages? So by common sense, we can say that the excess is 1. So this quantity defines the excess 1. So we have 200, we have 201 minus 200 equals to our excess, which is 1. So what if you use 210 text messages? So again, by common sense, we can say that excess is 10. Okay? And this quantity denotes your excess. So we have 210, which is your M, because you use 210 messages. So M is 210 minus 200. So you will get 10 as the excess text messages. And this is the condition. Okay? So I hope you understand your example number 3, and that is all about piecewise function for a mobile plan. Okay, so we used a piecewise function because it is wise for us to write it in pieces. Okay, so you will pay 200 pesos or 250 pesos if you use from 0 to 200 text messages, and you will pay 250 plus the excess of 200 text messages times 1, because each excess is charged by 1 peso. Okay? So that's your example number 3. So let us now proceed to example number 4. Example number 4, functions in real life. So a certain chocolate bar costs 50 pesos per piece. However, if you buy more than 5 pieces, they will mark down the price to 48 pesos. Use a piecewise function to represent the cost in terms of the number of chocolate. So again, in this example, we will be using your piecewise function. Okay. So again, let us identify the given, your independent variable, dependent variable, and the constant. So our independent variable, as we can read on the problem or the situation, it is not specified, just like our previous examples, that the variables are specific. So we can use our own variable. Okay, so the independent variable in here is the number of chocolate bars. Okay, we can use any letter of your alphabet to denote your independent variable, as it is not specified in the problem. So bear with me, let us use small letter n to denote the number of chocolate bars. Okay, and for our dependent variable, we will use, or as stated in the problem, it is the cost. So it will be the cost, or the total cost of chocolate bars bought. So as a basic notation for our function, let us use letter F. Okay? So on our problem, we will try to read. We have two constants, 48 and 50. Okay, so just write 50 and 48. So again, it is a piecewise function, and it will be wise for us to write it in pieces, or we can say that the resulting function goes this way. So n function of f. So this is your input, and overall, this will be our output. Okay, so again, writing your piecewise function, first let us write open brace. Okay, so understanding your problem, you will pay 50 pesos if, okay, you will pay 50 pesos per piece, but if you buy more than 5 pieces, they will mark down the price to 48 pesos each. So you will pay 48 if you will buy, and denotes the number of chocolate bars or number of pieces. So if you will buy more than 5, you will pay 48 pesos. Okay, what if you buy 5? So that will be equal 5. What if you only bought 5 pieces? Okay, so as stated in the problem, you will pay 50. And we will add 0. And to complete our notation, just like the other example, if you will buy from 1 to 5 pieces of chocolate bars, you will pay 50 pesos each, or per piece. But if you will buy more than 5 pieces of chocolate bar, you will pay 48 pesos each. So simple. So this will be our formula for buying 5 pieces of chocolate bar or less. So by common sense, we will pay 50 pesos per piece of each chocolate bar if we will buy 1, 2, 3, 4, and 5. You will pay 50 pesos each. But if you will buy more than 5, of course, it will be 6, 7, 8, so on and so forth. You will pay 48 pesos for each. Okay? So I hope that it's clear. Okay, so that will be about functions in real life as well as writing functions such as piecewise functions.